This is a download from BFM 89.9, the business station.
Good afternoon, this is Frida Liu. It's Tech Talk. Now, according to White Hat's 12th Website Security Statistics Report published last year, the annual average number of serious vulnerabilities discovered per website per year has been a significant reduction year over year from 1,111 in 2007 to 79 in 2011. However, the damage costs of web security breaches have been on the rise. Here with me today is Jim Manico, VP of Security Architecture for White Hat Security. Jim, what do you see as the most common web attacking methods?
Well, first of all, thank you so much for having me on the show. I think that's a great question to start with. The question is, what's the most common web application layer attack? I'm going to answer that in two ways. First of all, the most common vulnerability, like when we look at a website and look to see what security holes are in that website as part of our service, we find cross-site scripting more often than not. It is an incredibly common vulnerability. It's very difficult for developers to fix them because there's so many of them, and there are so many different techniques needed to truly stop cross-site scripting. But if you look at actual attacks against organizations, by far, SQL injection seems to be one of the main attack avenues that threat agents, that attackers are using to attack websites. So I think cross-site scripting is the most popular vulnerability, but the most common attack technique, no doubt, is SQL injection from the various statistics that we've looked at.
Why do you think that's the case?
Well, frankly, SQL injection is very easy to exploit. This is a vulnerability where developers who are building websites are not handling untrusted or tainted data correctly, and they use this tainted input to build a database query. And once they do that, they're basically allowing attackers to drive the structure of database queries. And what I mean by that is this vulnerability, SQL injection, it allows the attacker to change the structure of how this code talks to a database. And it lets the attackers pretty much steal any data from the database. And usually it lets them also modify any data in the database. It'll even let attackers do something called command injection through SQL injection. It's where the attacker is able to issue operating system commands against the back-end database. This is easy to exploit. There are many tools that make SQL injection attacks even easier. And frankly, even just manually typing in data into a web browser, it's not that difficult either. So because attackers can do so much damage with SQL injection to a website, and because they can do it easily, why use any other technique? That's enough for an attacker to get right to the heart of the matter and do damage and theft against the core database. That's why I think it's the most popular attack. Lots of damage, easy to do.
What's in it for them? It's the money.
Well, there's a variety of different impacts from a web application layer attack. So I'm going to go look at the OWASP risk rating methodology. This is a risk rating set of mathematics that folks can use to measure how dangerous a certain risk is. And if you look at the different factors for estimating the impact, this also gives us a good idea of why attackers do this. So number one, of course, is financial damage. It's why go rob a bank when you can do it from the comfort of your home through security attacks? That's financial damage. There's also reputation damage. So maybe a big company will say something that upsets a certain activist group, or a big company will say something that attacks a certain hacker group or offends a certain hacker group of some kind. So these hackers may want to attack an organization not to do financial damage, but just to attack their reputation or embarrass them in some way. So number one is financial damage. Number two is reputation damage. We also have non-compliance as a business factor impact. So I'm kind of changing the question a bit, but an attack that hits a business website, this may be a violation of various compliance laws or regulations that they need to do in order to do business. The common one we see is PCI. This is the payment card industry data security standard, which credit card processors must obey if they don't want to have increased fines or increased damages for using credit cards or for processing credit cards in their company. And by not securing their website in a certain way or by being attacked a certain way, they may be out of compliance with the PCI data security standard, therefore leveraging much larger fees on that company to process credit cards or possibly even have that company lose the ability to process credit cards. And so an attacker comes in, does a SQL injection, steals credit cards from a database that weren't stored correctly, and all of a sudden it's a huge it's both a combination of a financial damaging hit, it's a huge reputation embarrassment, and now this company is out of compliance with one of many regulations they need to follow to increase the damage even more. It might also be a privacy issue of some kind. And this is a combination of a reputation hit. It's a direct attack more on the individual customers, less so the actual company. It may be a violation of users' private information. For example, we see a lot of password thefts against major websites in the last couple of years. That might not just affect that website, and that might not just be damage against that website, but it's, first of all, it exposes individual users' passwords, and that may have a ripple effect on any other website that user uses where the password is being reused across multiple websites. There's a lot of impact factors when these attacks against websites happen.
Right. Can you give an example of a recent web attack incident that hurt an organization really bad?
I never want to point the finger at a specific company. These attacks happen so frequently. You can look at different databases like the Web Hacking Incident Database or look at any major news outlet, and they talk about these hacks on a regular basis. So I just don't like to point the finger at specific companies because you know what companies get hit through their web applications these days? Almost all of them. And so let me talk about more of a combination technique that attackers use. Very often against several major properties, we've seen a combination of SQL injection to do data theft, to steal passwords, and then expose those passwords publicly through a public site like Pastebin. This is they're using SQL injection to steal data, relatively simple vulnerability to exploit. They're then digging deep into the database in terms of how the password is stored. And this is another vulnerability. It's a vulnerability in how this company does a very specific kind of cryptographic storage, how they're storing their passwords. These passwords should be stored either with something called an adaptive hash. It should be a salted one-way algorithm, or they should be using an HMAC if they have proper key storage. And there are some basic cryptographic principles around how you store users' passwords. They should be verifiable, but not reversible. And many companies make the mistake of not doing that properly. So SQL injection steals data, steals passwords which are being stored in an insecure fashion, and then those passwords are dumped again to a public site like Pastebin where anyone can see the dump of all these passwords. That specific scenario has happened to several high-profile sites just in the last year. This is game over for that kind of website. For at least temporarily, it really limits that website's ability to continue to do its business function because of an attack of that nature. And again, that exact scenario, we've seen it many times within the last year.
Right. Are these types of attacks unstoppable?
Of course, there's with any major attack, there are ways to defend it. Like, for example, when you talk about SQL injection, the most important defensive theory we talk about is something called query parameterization. This is an esoteric computer programming technique that pretty much any programming language used to build the web has this capability. It's really simple too. It's not that difficult, and it, for the most part, eliminates SQL injection. There are a couple edge cases where that's not going to work, so you want a technique of good input validation in addition to query parameterization to stop SQL injection. And again, this is not that difficult. We look at other risks that I talked about, like password storage, being done improperly. There are plenty of methods to at least make it really difficult for an attacker to reverse the passwords. I also briefly mentioned cross-site scripting earlier on in this conversation, and there's a technique called output encoding, diffusing attack data in your user interface to eliminate most forms of cross-site scripting. There are also standards emerging to stop There are also standards emerging to stop cross-site scripting, such as the W3C standard called Content Security Policy. So yes, indeed, it is possible to stop these attacks. There's even different virtual patching technologies like web application firewalls. I prefer to fix the underlying code, but there are a variety of techniques and tools that will allow a company to build a more secure web application.
Right. I'm here with Jim Manico, VP of Security Architecture for White Hat Security. And in a while, we'll talk about steps to protect your website. BFM 89.9. Good afternoon. This is Frida Liu in Enterprise. It's Tech Talk. Jim Manico, VP of Security Architecture for White Hat Security, here with me. We talk about website security. And earlier on, we spoke about some of the common security breaches. Now, from the 12th Website Security Statistics Report, the annual average number of serious vulnerabilities discovered per website per year saw a significant reduction. So what does this mean? A website is getting more secure?
That's a difficult question. First of all, the honest answer is we really don't know. I mean, this is metrics, this is data, and there's so many different ways to interpret that data that we really don't have a solid answer of why we're, at least in our data that we've released as part of the White Hat statistics that we released in summer of 2012, our most recent report. We definitely do see a reduction in serious vulnerabilities, but why? So we have a couple theories. Now, it might be that sites are getting more secure. That's really possible. You know, at the same time, if you look at some of the statistics, there's a huge standard deviation, and there's a lot of reasons why that may not be true. We're not 100% certain, but that's one theory. It might be that sites are getting more secure. I doubt it, but it's possible. Second theory is that organizations may be choosing less comprehensive vulnerability assessment. Like they may be using a lesser version of our service or lesser version of other folks who do security assessment, and they may just be getting less thorough in how they're analyzing a website to see how secure it is. Or companies may be spending less money overall in assessing the security of their website. Another theory that we have is that the earlier sample of websites from earlier years was not representative. So if we look at June of 2012, Netcraft tells us there's 697 million websites, and that's increasing in the tens of millions per month. And we have assessed a large number of websites, but overall we have statistics for thousands, maybe tens of thousands of websites and what level of vulnerabilities they have when we're looking at 697 odd websites overall. So it may be that the original sample of websites and data that we and others have collected in previous years were not comprehensive enough. So that's a good question. I want to answer you as honestly as possible. The real answer is we just don't know.
Right. So what are the necessary steps you'd recommend to protect an organization's website?
Well, there's a variety of approaches. And let me take a step back and discuss the problem of how to even approach this issue around web security. When we look at things like network security, in a lot of ways it's commoditized. It's network firewall rules and proper network design and monitoring and patching, and it's a series of techniques that's fairly commoditized. We know how to approach that problem. When we look at a web application, think of even just a simple accounting application. Suppose I gave an assignment to 10 different programming teams to make me a very simple, 10-page basic accounting piece of software. Those 10 teams would all do it radically differently. They'd use different databases, they'd use different programming languages, they'd use different variable naming conventions, they'd have different endpoints in the actual application, and we're just talking a simple 10-page accounting site. Now, blow that out to 600-plus million sites, everyone using different technology, different teams. It's like clay. There's so many different ways to build a website, and that makes the assessment of them, and that makes the security of them much more difficult than other areas of information security. We're also fairly new at this, even though these attack types have been out in some cases for over a decade or more. That companies have only really gotten religion about approaching website security relatively recently. And so, back to the question: how do we approach security of a website? In my mind, this is largely an engineering issue. We need developers to write code differently. But you got to look at developers today. Developers went through school, and they didn't learn about security. Developers are are using languages that are fundamentally insecure, programming languages. Then developers have frameworks they need to use to build a website, and those are largely insecure as well. And then the business is tasking a developer to build a website with requirements, and those requirements rarely include clear prescriptive security requirements. And then the pressure is on developer to get it done. Are you done yet? I should be coding right now, not on the phone with you, and yet so the developers get all this pressure to write code fast, and security is something a lot of companies want to slap on at the end. And so if you look at a risk like SQL injection, although it's not recommended, we can fix it after the fact. If there's a SQL injection vulnerability, we can go in and efficiently fix it. But for some of these problems like severe access control design flaws, we really need to build that security in from the ground up. It's kind of hard to just add this in after the fact. So how do you build a secure website? You have to care about it. You have to provide developers with good education around security. They didn't get that in school. We have to have requirements that involve security. And one of the projects I run for a nonprofit foundation that I volunteer for is called the OWASP Developer Cheat Sheet Series. This is an OWASP resource. It's open source. And it's a list of tons of prescriptive things that developers need to do to build a more secure application. So we know these techniques, but it's a matter of, again, training developers, giving them requirements around security, giving them time to build security in, providing good assessment technology, dynamic and static analysis. Let's review their code for security vulnerabilities. Let's also try to hack the application ethically, looking for vulnerabilities. When we combine, and we also want to think about designing applications secure from the ground up. When we begin to approach all these things in like a ballet, in an organized, disciplined way, we begin to get good security. And without these things, we may get security by luck if we happen to have the right people working on our code, but more often than not, we don't get it. And this is why we see so many hacking incidents out there, but it is possible.
So that discussion about security should be made from the onset. Now, what do you think about web security, the web security awareness level in Malaysia or throughout the Asia-Pacific region as a whole?
I can't speak to Malaysia, and when I answer this question, I'm kind of shooting from the hip in terms of what I've heard from friends of mine in the industry and from conversations I've had in my travels. I'm taking a guess here. Overall, I think that the Asia-Pacific region and Asia as a whole, they tend to be behind on security, at least from the West, back a few years. So we have I think the U.S. and European banking industry was the first to really start to invest heavily in web security, and then other U.S. markets began to care about it, and then Europe is now beginning to get involved. I just think that the Asia-Pacific region is just a few years behind other regions, and that's just a guess. That's what I've got from stories from friends of mine. But I'll tell you, you know who's really immune to web security right now in the world? Nobody. I see major websites everywhere in the world getting hacked on an almost daily basis now. So no one is innocent here when it comes to this topic. I just have a gut feeling that Asian businesses are a little bit behind other areas when it comes to this topic. But again, that's just a guess.
All right. Thanks for sharing with us your thoughts. I've been speaking to Jim Manico, the VP of Security Architecture for White Hat Security. This is Tech Talk, BFM 89.9.
Thank you for listening to this podcast. To find more great interviews, go to bfm.my or find us on iTunes. BFM 89.9, the business station.